If you need a stapler, let me know. Today we're talking about composition of functions. Composition of functions. Composition of functions, composition of functions, composition of functions. Every time I teach this, reminds me of this, of one of my, actually, I've never actually eaten it. But you know this guy named John Madden? Like, of course, because he invented that famous video game. Have you actually seen him in person? Okay. All right. So John Madden, you know, like during Thanksgiving, he used to give out these turkey, like the turkey leg awards for like, you know, they still do. John Madden, then they asked him one day, he's like, what's your favorite thing to eat for Thanksgiving? Because they started talking about turkey, right? And he said, my favorite thing is something called a turducken. You know what a turducken is? Yeah, right. No. A turducken is they take a duck, they wrap it, they wrap it in stuffing, they take it and they shove it inside of a chicken. They wrap the chicken in stuffing. They shove that inside of a turkey, okay? And then they cook it. It is the single most unhealthy thing that you could ever eat. It has to be prepared by a butcher. They take all the bones out of all the meat, so it's just meat and like, okay, it does. It sounds amazing. Yeah. Okay. How does that remind me of functions? Because we are going to take one function and shove it inside the other. Yep. Yeah, exactly. Incredibly inappropriate. But anyways, here we go. Let's do A. F of G at 3. So here's what you do. When you are presented with something like this, you start inside and you move outward, So the first thing you need to find is this first. Find this first. Yeah. We got to find the G at 3. And G at 3 is just plugging 3 into its equation, so that's going to be like 3 squared minus 4, and 3 squared is 9, and 9 minus 4 is 5. Let's talk again. Some people are having some problems finding it. I'm taking it from that equation right there. There are two separate equations, one in green, one in red. I'm going to color in. So yeah. So I just took the green one. I found G at 3, which means I took the G equation, I subbed 3 in for X, found out how much it was. It was 5. This means really that G at 3, let's go with black. G at 3 is the same thing as me saying 5. All this could be condensed down to me just saying G at 3 equals 5. Right? It's like transitive property from geometry. Who remembers transitive property? Yeah? No? Not a single person. Yeah, there you go. G at 3 equals this stuff. This stuff equals 5. Therefore, G at 3 equals 5. That's transitive property. Okay, now let's do this. So this means F at G at 3 is the same thing as me saying F at 5. And then all you do is just sub it into the F equation. That's going to be 5 plus 2, and that's going to be 7. That's our answer. So take a look. Remember I talked to you guys about this all being a language? To make it even more confusing, some weirdo added even more symbols. You know what I'm saying? Oh, God. No, it is an O. It is an O. It's not a 0. Okay? This is the same as, sameses. It's the same as, and it's read from right to left, G of F at 3. It's just a really stupid, complicated way. There's no way to even try and put that into a computer now. It was just, I have no idea why you are completely correct. It has no purpose. None, to be honest with you. Except maybe to remind yourself that this is a of, but it doesn't even look like that. It can only be confused as a 0. It's dumb. But you're going to have to know how to read it. let's do this. We got to find g of f at 3. I always recommend that if you see stuff in this term, you just convert it to that one. How much is g of f at 3? So g of f at 3. The first thing we're going to do is we're going to find the stuff inside. We're going to find this. G of f at 3. We did a backwards version of it. We did it going the other way around. So f, that's going to be f at 3 is 3 plus 2. And that means f at 3 is 5. All right, to be honest with you, the confusing part about this is simply just reading it. There's no real complicated math aspect to it, other than just plugging stuff in. So here I'm asking for g at 5, and g at 5 is 5 squared minus 4. That's 25 minus 4 is 21. And there's our final answer. Yep. You go, Carly. Carly? Okay. Ready? G of f of x. So, let me just write it out for you. Right? I know we did. Here's f of x. How much is f of x worth? X plus 2. Very nice. So this equation right here, sorry, let me, it's not wrong. I just want to do it in two separate colors. So g of f of x. This is the same thing as me saying take the g equation, and into the g equation, we're going to sub x plus 2. And that's the same thing as me doing x plus 2 squared minus 4. That's it. That's all you got to do. I mean, you could multiply it out if you wanted to. You could. Or you could just leave it like this, unless they say to literally expand it out. I'm okay with that. Is that easier? No? Nope. Nope. Okay, that's A. Let's go to B. Let's play again. That was easy? Oh, it's the same thing we just did before. So you're judging the level of easiness by how many steps it takes to complete. Oh. So here we go. We're going to take the f equation now, and into the f equation, we're going to sub how much? Yeah, we're going to sub x squared minus 4. That's simply the same thing as, oops, x squared minus 4 plus 2. You're subbing it in. You're subbing it into the x spots. How about this one? Let's play again one more time, subbing equations into each other because, well, sometimes they're not as nice as the other ones we just did. How about A? Okay. How about A? F of h of x. So we're going to rewrite that. That's the same thing as me saying f with h of x shoved into it. All right. Sure, let's plug it in. We're going to be f, and inside the f function, we're going to plug 3x plus 2. Oops. 3x plus 2, let's see, equals 3x plus 2 minus 2 over 3. Yeah, that's basically it. But we got to reduce it. We got to reduce it. That you can't leave like that. 3x over 3, and that's just x. Okay. One more thing to go over. One more thing to go over before we talk about maybe homework, okay? Or we can go on to new stuff. But homework, okay. So here we go. So now we have graphs. Now we have graphs. Where are you going to find g of 4 at j? Well, how much is this? This is going to be the same thing as, you got to solve it from the inside out. G at 4. G at 4 is how much? G at 4 is 3. So instead of saying G at 4, I'm going to say 3. And how much is J at 3? 1, 2, 3. J at 3 is -1. And so that's how it works. You jump from one graph onto another. It's on your paper. Sure. Absolutely. If you're an economics major, you can't fit all the graphs onto one graph, right? You have to jump back and forth between them. But sometimes graphs are related. So finding one number on one graph, you jump over to another graph and find where it corresponds. What's up? Okay, all right. So here we go. G at 4. So we find G at 4. G at 4 is 3. Right? So instead of saying G at 4, I say 3. And then, since we're subbing G of 4 out, we're saying 3, then you find J at 3. J at 3 is -1. How do I get 3? G at 4 is 3. Okay? Okay. All right. Let's do B. J at -1. Take a look. No. J at -1. J at -1 is 3. So this is the same thing as G at 3. And how much is G at 3? 1, 2, 3. How much is it? It's 2.